into is not rain or cool. What does it mean? Do our brain very easily understand it. So how this happens is, what is the that is the comprehension of this conversion is, I will be accepting this statement if it is not raining or if it is cold. In both the situations, I will be accepting the statement. So now, if somebody says this, this is going to happen. This is about what he is saying, and we are going to evaluate it. To evaluate it, we convert that into another form of when this thing will be accepted. So this is not happening in the brain. This is not plausible with respect to our brain. So these are equivalent. We understand that this is being proved one with a truth table, very simple truth table. We can say that the truth table for this implication and this not P or Q is going to be same. This is a very basic lesson in terms of first order logic. But is it biologically plausible? That is the question we raised against. And then why can't we use as it is? Our model will help implementing these instead of converting these things. So again, this is also a conversion problem. Whenever you say a statement, the agent cannot say like this. So for example, if an agent is a doctor, so then he has to say something. If he has a fever, then it implies that his some condition is prevailing. If he say that, so then there should be some other person, assistant to an agent, who knows about this first order logic. He has to convert that into these kind of statements and then put it into a particular environment, in a computing environment, and then evaluate it. So this becomes a more complicated issue which is happening, and we also feel that because of this kind of thing, the work or the agent communication or straight away working on the machine system he is kept away. Even though the real agent, there will be a pseudo agent who will be doing this conversion, and he will be the agent to the particular person. So there may be a problem of that is misinterpretation or misconversion what a particular doctor says also. This can also happen. So we do not want to go into those kind of discussions now. So we do not want these things to be eliminated. They not only eliminate this one, they eliminate this there exists is another symbol which we are not, which is not in this example. So that there exists, they are eliminating, and finally what they also remove this for every, because or for all. So that is, they consider that everything is, whenever we say food of X means for all food. That is how we have to infer. So they also remove this symbolism. So these symbols are removed out of the statements, and a blatant facts are given into the table. So this is what all of us should be remembering it. So to reiterate, I went through this thing, and if these type of statements are available without conversion, can we do the that is inferencing? So to understand that, the inferencing is also done in two fashion. One is that is forward chaining, and other one is backward chaining. So the inference engine follows these two. So the prologue does not support forward chaining. So we have to go for PS5, which I have already mentioned there. PS5 follows forward chaining, and the prologue follows only backward chaining. So what about that? We will be coming into that now. So now, taking up this example, we will get into the using backward chaining, how the inferencing can be done in backward chaining in our environment. So in our environment, a neuron is considered as a function. So a neuron maintains some informations, and it receives signals, and then it reacts something. It does some work with the information what is received. According to the information it receives, it does function. It may message to outside, or it may do some modifications to its information. So here we assume that that is how we have defined in the object based model. So it can receive signals, it can receive multiple signals, it can work on choose one signal and miss another signal, or take into consideration all the signals. All these combinations are discussed in the first work itself in the object based model of neurons. So now here I will concentrate only on what we are assuming. Here we assume that this is what are all the predicates here is, likes is a predicate. So I will just underline them. Likes is a predicate, food is a predicate, then eats is a predicate. So now, for simplicity in the initial stage, so the not killed means alive, alive means not killed. So that complication is removed from them For the initial complication, what I consider it as, if it is not killed, I will consider it straight away, I will consider it as alive. I will consider that as alive. Alive of X. Both are same. Alive or X. So now, so that is what here we have, we add two predicates here. So instead of going into these predicate representation and confusing things, I straight away assume I eliminate this not killed, I take it into consideration only alive. I am removing this not killed consideration. I will take one more predict which is called as alive. So we are going to take only four predicates. That is four predicates. One is flags, this one is food. Food, I have not typed here. This predicate represents food and eat, and this one is alive. Alive. So now, in this situation, what happens here is, whenever a statement is given, so it represents a predicate. So now here what happens, you have to understand this, food of X, food of X means there should be something called as food, should be a predicate called food. There should be a controlling section for this network, which as we have discussed that. So the controlling section receives this information and then it constructs this particular network first. So that will be the first stage of the thing. To construct a network, how do we identify how many predicates or for how many neurons we have to create? So now, if for a food we have to create, whenever this statement comes, you understand, very easily understand that you have two predicates. So two predicates are created, and this food of X implies likes of S. So now in the, we are seeing about backward chaining. How we do it here is food of X implies likes John of X. So now this is not likes John of X, is a clear error. So now this is where it is defined here. What is defined here? What John likes. John likes something. What something is? It is food of X. So now it is a definition or it's a rule of a, it is not, it is a specific rule. It is not a generic rule. We have to understand that we differentiate the rules into specific rules and generic rules. So the specific rules get into the particular predicate itself. So likes John of X. So means what is replaced here, in the place of X, food of X is replaced. So John food of X. So now here we call it as a rule, that is a particular specific rule, or it is not a definer of this like. What is liking means we are not defining it. We define only what John is liking. So now when we define about likes, so then it will be called as the generic definition and or generic rule, or when it defines about a particular liking of a particular person, so then we call it as a member. So then John likes, so John likes food of X. So you have to understand, relate it this way, John likes food of X. So then that is, now this whole statement has gone into a particular area. So now you have understand, you have to compare it with the that is a knowledge graph. What happens here is, in the knowledge graph there will be a relation, there will be a subject, predicate, there will be three things available. So now, so whole of this function gets into a single area. So now John food of X. So this is, as this is a function, it is not a data, as it is a function or as it is a running procedure. So this can hold some data within it. So or it can maintain different lists also. It can maintain lists. So it maintains a list of facts. So when in the list of facts, that is a John likes food is a fact. So the member of this, so we can say that predicates with the multiple variable predicates or a single valued predicate. So when I say food of X is a single valued predicate. Likes is John likes, so it is a two varied predicate. So now in this situation, John comma food of X is being replaced here. So then first step we have over. Then we get into food apple. So now food apple means, now it may have, these are all facts. So just you add a member here, food apple. So this one is going, and if it is and, so the and can be divided into two facts. That is quite obvious. We will be doing it if both are true. So food is apple true, and food is vegetable is a food is also a truth. So now this is true, this is true. We are added into this one. So then what happens is, now if you see this here, it is food of y. So now whenever we say food of y, it is a generic rule. It is a generic rule. So now this generic rule is food of x is equal to, what is food of x? Eat x comma y. So something is a food if something is eaten by some x, is it clear or not? Somebody, and then that person is not killed what they have given, and that person is alive. We have simplified it, and that person is alive. So we replace it with eat x of y and alive x. So now we are having two list here. One is about the facts, straightforward facts, and other about the rules defining it. So we have divided a particular that is a function or a procedure or a neuron according to us is having two lists maintained in it. So that is eats x of y, that is for the generic rules, and then for the facts involved according to it. So this is what we have done. So then we will get into the other facts. Here eats anil, peanuts and alive anil. So now what happens here is eats, you have a truth, anil eats peanuts. So that is being added here according to this statement. This one is now, and alive anil is added here. So now we have, so we need not worry about this Harry anil of x. We need not worry about this eats anil of x, eats Harry x. So now this is a specific truth. So now what Harry eats? Harry eats whatever Anil eats. Harry eats whatever Anil eats. Anil eats x. So it's a recursive definition. To be explaining the recursive definition is also possible. We are saying this here. It is Harry eats what Harry eats, anything Anil eats. Anil eats X. So if X is eaten by Anil, then Harry will also eat it. So that can be that can also be represented here. So now our query is whether John likes peanuts. Whether John likes peanuts. So now in this case, how we are going to calculate John eats peanuts. So this is a question coming from. So the first phase is over. Defining all these, constructing this network is over. So now the second phase starts. We are giving a questioning here. So that is whether John eats peanuts. So if this John peanuts, so here there is no John peanuts. There may be somebody would have told you that John eats peanuts. That would have been a fact here. If it is given, straight away you can identify John eats peanuts. Otherwise, you have to go backward. So that is, you go backward chaining, you have to apply. So then for backward chaining, what we do here is John eats peanuts. So instead of peanuts, we replace it with food of X and then send it to this person, food of X. John, because it is a definer here, John food of peanuts. John food of peanuts. So now this is a question here. So do we have food in the list of food? We do not have peanuts. If that is there, you can straight away replace it with the truth value, and then you can identify that the whole thing is true. That can be decided here itself. But we do not have peanuts as a food here. So then what happens here is you have to go for Anil peanuts. So now what he is, this food of peanuts is replaced with two things. What is eat x of peanuts, alive of x. So that information comes here by replacing. Here this is called as substitution rules, which we already apply in predicate logic. So this food of peanuts is replaced with eat x of peanuts.